My dear students and 2023 GATE aspirants, a very good evening. The long-awaited GATE exam is finally over, and the moment has come to evaluate our performance. As all of us tell you in the class, in order to succeed in the GATE exam or any competitive examination, it's not the quantity of what you study, it is the presence of mind that will make the difference. So going through today's paper also, you would have felt it. To know your performance, we are here to analyze the paper in ECE for the GATE exam. I have along with me a plethora of ECE professors to discuss about what questions have come in the exam and what are the solutions for them. As you know, these are all memory-based questions. With great difficulty, we have collected all the questions from the students who have appeared for the exam today. That's the reason there may be little deviation in the problem statement as well as the values given in the exam. So the final paper, we are going to discuss it in future. 99%, we have collected all the questions in accurate manner, and we are going to discuss it one by one, and you can understand what is the correct solution for that, and you can evaluate your performance. I going to give what is the distribution of the marks given today's exam, and after that we start with subject by subject discussion. Thank you and wish you all the best. Yeah, let me give the overall idea about how the questions have come in this 2023 GATE examination for ECE students. So these are all the subjects, and in 2023, these are the questions that have appeared. As we always say, there is no important subject, unimportant subject for the GATE examination. We can get questions on any subject in any manner. So as I told you, you need to be good at fundamentals so that you can tailor them properly and understand what is the solution for the given problem. As you can see here, this is the 1 mark question and 2 mark questions given in each of the subject. Almost all the subjects are having equal distribution of the marks. If you look at how the MCQ, MSQ and numerical answer type questions are given, this is the final thing. MCQ questions are 45, MSQ questions are 4, and numerical answer type questions are 16. Of course, this is totally 65 questions. Some of them are 1 mark questions and some of them are 2 mark questions. And the importance, as I told you, the number of marks given, they will differ year by year. So that's the reason we have given a comparison about the marks we have obtained in each subject compared to the previous years. So you can compare here in 2023 what's the weightage, and earlier in previous years how the questions have come in the corresponding subjects. So almost all the subjects are having equal importance, and we should see how we have performed in all these questions so that we can evaluate your performance and know the GATE rank. So in this regard, I request my dear colleague, Professor M. Narasimha, to come and discuss the questions on signals and systems. Thank you.
Thank you, Dr. Chakramani, sir. Hi, friends. In today's exam, we got 4 2 marks and 3 1 marks questions from signals. Let us see the models that were asked. Let M of t be a band-limited signal with bandwidth of B having energy E. Let omega naught is 10B, then energy of the modulated signal M of t cos omega naught. For our easiness, I am assuming some spectrum, band-limited spectrum, which covers from minus B to B. It is band-limited to B. According to Parseval's theorem, what is Parseval's relation? 1 over 2 pi, energy in the signal is 1 over 2 pi integral mod x omega whole square d omega. Because it is band limited, we are varying from minus B to B. Assume amplitude like 1 whole square d omega. That result after simplification is B by pi. Let us name this new function like m of t cos omega naught t. What is the Fourier transform of this one directly? Modulator. We can select that as m of omega minus omega naught plus m of omega plus omega naught by 2. So the original spectrum right and left shifted by how many units? That omega naught units. Omega naught is mentioned as how much in the question? 10B. Omega naught is 10B means it will cover the range 9B to 11B. Similarly on the negative side. What is the change in the amplitude level? Original 1 extra multiplied by 2. Find out the energy in this spectrum using again our Parseval's theorem. So energy in the spectrum is 1 over 2 pi. Of course it is symmetrical spectrum. Minus 11B to minus 9B, amplitude 1 by 2, 9B to 11B also 1 by 2. So minus 11B to minus 9B, 1 by 2 whole square. Similarly 9B to 11B, 1 by 2 whole square d omega. That becomes what? 2B by 4, 2B by 4 by 2 pi. So overall becomes how much, sir? B by 2 pi. What you got? Energy of original signal, B by pi. Now how much you got? B by 2 pi. So in terms of energy in original signal, you can say E by 2 is the result or not? Such an easy model. Simply application of Parseval's theorem, extra modulation property. Extra modulation property. Very easy model. Let us see the next possible model. This is a habituated model in classroom discussion. As we are ECE fellows, every fellow aware of Gaussian function nature. Correct or not? The standard formula for Gaussian function is what? E power minus at square. Fourier transform root pi by a e power minus omega square by, or root pi by a e power minus pi square f square by a. What is a number? 1. So substitute there. According to the signal given, a value 1 root pi into e power minus pi square f square. Simply a plus 1 in the standard formula. You may apply the property also, but who are thorough with that relation, easily they can say the answer. Standard relation. Correct or not? Okay, let us see the next question that is given. This is another funny model. Input spectrum given, system response given, he wants output. It is a habituated model, generally has finite length signals convolution. If they fail in time domain, they may use transform domain. Normally, they will habituate to use Z transform. This year emotion is towards DTFT, discrete time Fourier transform. Normally, what is the Fourier transform of del n we know? DTFT of del n is, so del of n minus n naught means e power minus j omega. So based on that, what is the inverse we can write here? Inverse Fourier transform of x of n data, what you can write? 1 means del n, next del of 2 into del of n minus 3. In a similar way, what is the inverse we can write here? H of n. 1 means del of n, half into e power minus 2j omega means half into del of as a set of samples, how we can represent them? As a set of samples, 1 comma minus 1 comma 0 comma 2. In hurry you may miss that, be careful. Of course, you have done the exam. Del of n minus 2 is not available there. Means their amplitude is how much? 0. H of n samples are what? 1, 0 minus half. Because here del of n minus 1 is not there or not. Just convolve them. That will produce the output. So when you go to, let us see how we are doing convolution of these two simple techniques, sum by column method. From our last slide, what is xn and hn data? From the last slide, sir. What is x of n samples? 1 minus 1, 0, 2. 1 minus 1, 0. What is h of n samples? 1, 0 minus half. 1, 0 minus half. Do normal multiplication. 1 minus 1, 0, 2. When you multiply by minus half, just add them. 1 minus 1 minus half, 5 by 2, 0 minus 1. This is the output result we got. With respect to index form, what is the index? 0, 1, 2, 3, 4, 5. So you can compare with the given expression. You can compare with the given expression. So it will look like which option? First samples are what? 1 minus 1 minus half minus 5 by 2. Is it minus 5 by 2 plus 5 by 2? So that will look like which option? First option or not? Very simple. See the samples. 1 minus 1 minus half, 5 by 2, 0. At 4 it is 0, 5 it is minus 1. That will make that answer or not? Let us see this. This is a good question. In pre-gate exam, I asked this model. You can cross check. Same question I asked spectrum, impulse response. Input known, system known, get the output, convolution converted to multiplication, simple logic. Whenever the input is sinusoid, what is the guaranteed outputs are? Sinusoid. For first getting SAS square function Fourier transform, which is a triangular spectrum, we are using which property? Multiplication in time domain. x1t multiplied by x2t is 1 over 2 pi x1 omega convolved. So sin omega naught t by pi t into sin omega naught t by pi t. So if I take Fourier transform 1 over 2 pi, one rectangle covers from minus omega naught to omega naught, convolved with another rectangle covers from. If I take Fourier transform here, that will look like a triangle. That will look like a triangle. Correct or not? Use our area property. The peak amplitude is omega naught by pi. Extra pi is already given. Extra pi is. So if I am introducing that pi also here, if I am introducing that pi also, that becomes what? Of course, by 2 is there, omega naught pi cancellation. If I feel this function like h1t, pi into this entire term, if I feel like h1t, what is h of omega? h1 of h of t into cos omega naught, again modulation property. h1 of omega minus 10 omega naught plus h1 of omega plus 10 omega naught whole divided by 2. You feel this like h1 of omega. Means this triangular spectrum right and left shifted by how many units? Plus or minus 10 omega naught units. Plus or minus 10 omega naught units. Where is our original spectrum? What is the range of original spectrum, sir? Minus 2 omega naught, 2 omega naught. For that what we are adding? 10 omega naught we are adding. Correct or not? 10 omega naught we are adding. So what will happen? That will cover which range? 8 omega naught to 12 omega naught. 8 omega naught to 12 omega naught. Of course, there will be some amplitude changes. Okay. What is the input function we applied, sir? 10 cos of 10.5 omega t. 10 cos of, whenever the input is sinusoid, output is guaranteed to be sinusoid or not. Okay? At 10.5 you have to see the exact amplitude change. What is the simple logic? There is no need to waste your time by finding this ramp expression. What is the simple logic? For this width, what is the height? 10 omega naught to 12 omega naught, 2 omega naught, what is the equivalent height? For 2 omega naught, it is omega naught by 4. You want the amplitude level where? At 10.5 omega naught or not? What is this gap now? Respond. 10.5 to 12 means what is the gap? Just 1.5 gap. For 1.5 omega naught gap, what will be the amplitude? It becomes 1.5 omega naught into omega naught by 4 divided by 2 omega naught. That extra amplitude will be introduced here in the output. I have not exactly remembered the expression because the options are not available. Input sinusoidal, output also sinusoidal. A cos of the 10.5 omega naught t plus theta form. What is A? The scaling factor is A. Funny thing, modulator questions are two questions. Frequency shifting property, that energy based question you can solve by modulation property. This question also solved by modulation property. My friend, faculty friend, Mr. Aditya will discuss the other models. Thank you.
This question is based on convolution. They gave x1 of t, x2 of t is also given. They are convolving this two waveforms. The resultant waveform is denoted as y of t. They are asking what the value of integral minus infinity to infinity y of t dt. It's a convolution property. So integral minus infinity to infinity y of t dt. It is equal to integral minus infinity to infinity x1 of t dt into integral minus infinity to infinity x2 of t dt. So just find what is the area under x1, area under x2, and then multiply. What is this? It's a rectangular pulse from minus 1.5 to 1.5.
They gave two waveforms, x1 of t and x2 of t. They are convolving and the resultant waveform is denoted as y of t. And they're asking what's the value of integral minus infinity to infinity y of t dt. It's a so simple question based on convolution property. According to the convolution property, integral minus infinity to infinity y of t dt, it is equal to integral minus infinity to infinity x1 of t dt into integral minus infinity to infinity x2 of t dt. Just find areas under x1 and x2, multiply them, that's the answer. Now the first waveform is a rectangular pulse from minus 1.5 to 1.5 with height 1. So the area is, the width of the rectangular pulse is 3 and the height is 1. So the area is 3 into the area under the second one is, it has an impulse at minus 3, impulse at 2 with this 2, you have to be a little careful, and a rectangular pulse from minus 1 to 1. So area under this impulse is 1 plus area of this rectangle is 2 times 1, that is 2, plus area under this impulse is 2. So this is 5, 5 into 3 is 15. So there is another question like this. The input-output relation is given as y of t equal to x of e power t. And they're asking whether the system is causal or not and time invariant or not. Now let's check the causal system. So let's find what's the output, or how do you find y of 0? So y of 0 is x of e power 0. E power 0 is 1. So now what do you understand? This is the present output and this is the future input. Hence it is non-causal. Now let's talk about time invariance. Now in time invariance we need to check two things. One is what is the output due to delayed input and delayed output response. So I'm just first finding the output due to delayed input. Okay. So what would be the output due to delayed input? It would be like this. It would be x of e power t minus t naught. So this is equation 1, let's say, and let's also find the delayed output response, which is like this. Are they both same? They are not same. Hence it is time variant system. Therefore the answer is non-causal and time variant. Now another question appeared like this, which is a very standard model. So if it is continuous in one domain, then it is aperiodic in the other domain and vice versa. If it is discrete in one domain, then it is periodic in the other domain and vice versa. Now accordingly you have to match the options. So these are the questions from signals and systems. Next we have EDC.
Hope you have done very well in the examination, right? So I'll discuss questions from electronic devices. See the first question, in a semiconductor, if the Fermi level, okay, he's talking about Fermi level, lies in, I think lies, okay, in conduction band, okay? It is present in the conduction band, nothing but what? Above EC, the Fermi level is present, right? Then what is the semiconductor? So we know, see if I see the intrinsic semiconductor, the Fermi level is at the middle of the energy gap, right? Then if I take the non-degenerate semiconductors, non-degenerate p-type means it will be in the forbidden band, right? And it is close to the valence band and above the valence band. If it is a degenerate n-type semiconductor material, in this also Fermi level is in the forbidden band, but it is close to the conduction band and below the conduction band. So in case of degenerate semiconductor materials, it will be in the conduction band or it will be in the valence band, nothing but if the semiconductor is n-type degenerate semiconductor, Fermi level will be in the conduction band. In case of p-type degenerate semiconductor material, Fermi level will be in the valence band, right? So this we clearly discuss in the class, okay? So there is no much time to spend here, right? So directly what I can say, because it is in the conduction band, it is degenerate n-type semiconductor material, as simple as that. Now let us see the next question. Now in a semiconductor material, he is talking about, he has given where the Fermi energy level is located. So Fermi level is 0.35 electron volts above the valence band, right? Now what we need to calculate here? The concentration of the holes, right? So straight formula which we know, P is equal to what? NV into e power minus of EF minus EV divided by KT, right? Straightforward formula. Now, see, try to understand here, he has given at what temperature we have to calculate? 400 Kelvin. See, many times we'll mention this point, when you are reading the question, the information, each and every word is going to be very important, okay? Because temperature is not at room temperature, it is at 400 Kelvin. Now, given the NV value, that is effective density of states at the edge of the valence band is given, as well as KT value is also given, but these values are at the 300 Kelvin. But where you have to calculate? 400 Kelvin. So the first thing that what we need to do here is, sorry, first you have to calculate this KT value, right, at 400 Kelvin, as well as this NV also at 400 Kelvin, because both are dependent on the temperature. So now I want to get KT at 400 K, right? So with this very simple thing, what I can write? It is KT at 300 Kelvin, right, into 400 divided by 300. Now KT at 300 Kelvin value is given 0.026 electron volts into 4 by 3. So you just calculate this, this will give you 0.035 electron volts. Now what about NV value? So we know what is NV, right? What is NV? NV is 2 times of 2 pi MP KT by H square whole power 3 by 2. So it is very clear from this, NV is proportional to T power 3 by 300 Kelvin, right, into 400 divided by 300 whole power 3 by 2. So this is 10 power 19 which is given in the problem, and 4 by 3 whole power 3 by 2. So this will give you 1.54, right, into 10 power 19 per centimeter cube. Now all the values we know, just put that. What is the concentration of holes I can write now? P is equal to, NV value is this, 1.54 into 10 power 19 into e power minus of, so EF minus EV is given in the problem because the Fermi level is above the valence band by 0.35 electron volts. So this is 0.35 and KT 0.035. So you just calculate this. So this will give you the value 6.99 into 10 power 14 per centimeter cube. Right? So straightforward formula only, but you need to take care of the value of temperature where you are calculating. Okay. Yeah, the one more question from EDC will be discussed by MM Trinath sir, followed by the analog also, analog circuits. Okay, thank you.
Hi, students. This is MM Trinath, faculty of ECE Academy. Students, I hope you gave up your exam and done this. Yes. Right. Anyways, I wish you very good success in your future. This is the numerical what I got from the students of ACE Engineering Academy who gave up today. So MOSFET numerical, guys. So this is an integrated circuit analog IC design. Right. So this is a purely design system. If you go through the circuit, it is very clear that this is representing a perfect current mirror circuit, correct or not? For example, guys, if I check it out, I have M1, if I use the word M2 and M3, right? And M4 and M5, right, guys? So M1, M2 strictly behaving like a current mirror circuit. M1, M3, yes, it is a current mirror circuit, and of course, it is a PMOS design. Whereas M4, M5, yes, it is again a current mirror circuit. One of the previous gate question models here, the instrumentation as well as electronics and communication, one of the previous gate question models. Guys, if you check it out, I believe you can understand as per the current mirror, if I take this is a reference current, right? Then this can be taken as a copy current, am I right? Copy, let me say copy 1, and this is like a copy 2, right, guys? So for these two current mirror circuits, okay, so this is like a reference current, a basic current source, this is right, and this will act as a load, so I naught, or I can say I copy. What is the formula, guys, if I want to find I copy from my reference? What is the formula? So the reference current by that MOSFET W by L with, correct or not, W by L ratio. So this MOSFET W by L, this MOSFET W by L is nothing but 1, which equals to I copy 1 divided by that W by L. So it is 10. So we got I copy 1 as like a 10, and of course it is milliampere. Guys, correct or not, my dear boys and girls? So it is, once again repeating, I reference by 1 is equals to I copy by, what I say, it is 10. So I copy is equals to 10 into 1, because I reference is nothing but 1 milliampere current I am getting here. So I copy, I got it as how much, guys? 10 milliampere. Okay, fine. This is the current I copy. In a similar way, if you check it out, this as M1 as well as M3 together, again it is acting like a current mirror circuit. Then what is the formula, guys? I reference by W by L value, which is 1, is equals to
and I copy 2 because this is acting as a load for this M1, right? So I copy 2 by that W by L ratio, which is 7. Therefore, here I copy 2 is nothing but 7 into I reference, where I reference is 1 milliamps. So it is simply 7 milliamps. This is very interesting. I believe you're able to understand this, guys. So I copy 1 as well as what, guys? I copy 2. Now, in the similar way, if you go through here, dear students, M4, M5 itself again acting as a current mirror, true or not? So for M4, M5 point of view, now this is acting like our reference current for NMOS, correct? NMOS current steering circuit, NMOS current mirror circuit. This is acting like a reference current. Am I right? Let me say this is I copy for NMOS. Now for this, what would be the formula, guys? I reference whole divided by so 10, correct or not? I reference by W by L ratio, I reference by 10, so I reference by 10, which equals to I copy by that W by L ratio, so I copy by that W by L ratio, which is so-called 5. Now please let me know, guys, what is I copy here? I copy is simply equals to, so 520, right? So I copy is equals to 5 by 10 into I reference. Let me know, guys, what is this I reference? Is I copy 1, and I understand I have calculated I copy 1 from here, which is so-called 10 milliampere. So here this is 10 milliampere. So now I got it as a 5 milliampere. Is this correct? Yes. I copy 1 is simply equals to how much, guys? 10 milliampere. So substituting that 10 milliamps here, so it is like a 5 milliamps I got. Now let me know, dear students, we are supposed to find the value for V0. So simply find this current. Let me say this is Ix. I believe we can do that right now. So why don't apply KCL over here? Let me say it is X. If I could apply KCL here, I copy 2 is equals to I copy plus Ix, correct or not? So I copy 2 is equals to I copy plus Ix. What is I copy 2 I got? I copy 2 is 7 milliamps, which equals to, what is I copy? Exactly I got 5 milliamps. So this is 5 milliamps plus Ix. Therefore, simply Ix is equals to 2 milliamps. I think it is done right now. We are supposed to find the voltage V0. Yes. So what is V0, guys? Simply Ix into 1K. So simply this is like a 2 volts. So the output voltage, what we got in this given numerical so-called 2 marks. Numerical answer type questions, what I came to know from our students, okay? So if this data is correct, then absolutely this answer needs to be correct. The output voltage V0, what we got here is 2 volts. I believe you're our students, you must be doing this numerical very fast, right? Let's enter into another question what we have experienced. This is the data given by our students who gave up the exam today. If this data is correct, then watch out the question carefully, guys. The circuit obey which of the following condition? Current control voltage source, current control current source, voltage control current source, voltage control voltage source. This was what actually our students has discussed. Okay, fine. If that is the case, if you check it out, this circuit carefully, guys, yes, it is very easy, numerical, I believe. This is a PMOS design, this is NMOS design. And here, for NMOS, you are giving input at the source, excuse me, correct? Input is given to what? Source. And output is taken across drain. Input is source, output is drain. Itself represent, it is a common gate. It is what, guys? Common gate. So, if I say, if I consider this as like input resistance, source resistance is always a smaller resistance value. So input resistance, I could say, it must be very small. Whereas the drain resistance, so-called output resistance, drain resistance R naught, which will be very large for sure. Am I right? Now let me know, guys, input resistance is very small. Output resistance is very large. Input resistance is very small. Output resistance is very large. Yes, you're correct. This is best suited for current amplification. lower input resistance, higher output resistance, best for current amplification. If I say it is a current amplifier, then it is perfectly used as a current control current source, because an amplifier must be an active device. So current control current source must be apt for this given new variable. In a similar way, if I go through the next question of electronic devices, okay, EDC, electronic devices, because two questions I have done with analog circuits. Let me go with electronic devices. So how much time we are taking to solve it? That is very, very, very important, as you already prepared for the competitive exam called GATE under ACE Engineering Academy. Now guys, if you check it out this question, in extrinsic semiconductor, the whole concentration is given as extrinsic semiconductor, it's okay, or external semiconductor. Some semiconductor they have specified the whole concentration, they have given whole concentration given as 1.5 Ni, fine. Whereas Ni is an intrinsic concentration. So Ni, they have clearly specified as 1 into 10 power 19 per centimeter cube. My God, large intrinsic concentration, it is fine. The ratio of electron to hole mobility, that is mu n by mu p, is how much? Okay. Electron to hole mobility is how much? Where the condition is what? Electron drift current and hole drift current, they are given it as equal. Very interesting. The currents are equal. Electron drift current, hole drift currents are equal. I think it is very easy question. We can easily solve it. So how can we solve? Students, please let me know. Please let me know. We can understand that. What is the drift current formula, guys? Drift current. Let me say if it is for electrons. So NAQ mu n into electric field. Am I right? NAQ mu n into electric field. In the similar way, drift current for holes, if you check it out, PAQ mu p into electric field. Fine. The drift current for electrons, drift current for holes. They have clearly specified that electron and hole drift currents are equal. That means what exactly they have given? I drift of electrons with the I drift of holes. They have given as equals to 1. Now please let me know if I divide that ratio equating to 1, then I believe I'm going to get here it as n mu n by p mu p is equals to 1. I think I'm right. All the other parameters, common parameters, if I could nullify, n mu n is equals to p mu p. I need to find relation between mu n and mu p. So if I could know what is relation between n by p, then I'll be getting the answer. Guys, I think you can understand at equilibrium, right? At equilibrium, we know that. At equilibrium, we know that mass action law could be implemented. Product of electron and hole concentration at a given temperature is constant. So n dot p is simply equals to what, guys? Ni square. So therefore, p is simply equals to Ni square by n. That means to solve this condition, I'm using the condition of equilibrium. That is very important. I'm using what, guys? Condition of equilibrium. So now let me know p is equals to Ni square by n. What is n exactly, guys? Okay, p they have given 1.5 Ni. So they have given p, right? They have given p. Then n is equals to Ni square by p. Let me know, guys, what is p they have given? N is equals to Ni square by, what is p? 1.5 Ni. This is like 1.5 Ni. Therefore, here I got n is equals to Ni whole divided by 1.5. Wow. Now I got the value of n in terms of Ni. I got the value of p in terms of Ni. Why don't I substitute here? Now speak out, guys. What is n? What is n I got? N is equals to Ni. N is equals to what, guys? Ni by 1.5 into mu n whole divided by, what is p? 1.5 into Ni into mu p is equals to 1. Can't I get this answer? Yes, if I could solve, I could easily get the answer, guys. And if you could solve, you'll be getting the ratio as 2.25. Mu n by mu p is equals to 2.25. How simple we got. This is again a 2 marks question. I think you guys really rock like anything. Okay, now let my friend network theory Hanumantarao sir going to be continued.
Okay, so let's look at an op-amp question. I was told that there is an inverting amplifier with an input Vi and a non-inverting amplifier, and this combination is given to an adder circuit. This combination is given to an adder circuit. Now this is a weighted adder. You are asked to find what is the output. V0 by Vin. So what is V0? If I take this node as Vx and this as Vy, so how do we solve this? So by applying superposition, V0 is minus R4 by R3 times of Vx plus Vy. But what is Vx in an inverting amplifier? It is minus R4 by R3 minus R2 by R1 times of Vin, and this is a non-inverting amplifier, 1 plus R2 by R1 times of Vin. So this R2 by R1 gets cancelled, V0 by Vin is going to be minus R4 by R3. So this is the solution to this problem. So this is an inverting adder, inverting amplifier and a non-inverting amplifier. It is given to a weighted adder, okay? So this is one question. The second one, if I remember, you are asked to draw the transfer characteristics of a simple diode problem like this. Now, it is given that the VD on is 0.7 and you are asked to draw the transfer characteristics of this problem. So how will you draw this transfer characteristics? Given two diodes D1 and D2. So let us see when D1 is on. We know that a diode is on only when the current flowing through the diode is positive. The current flowing through the diode is positive. So let us apply a simple loop equation here. Minus Vin plus 0.7 plus ID1 into 1K plus 1 is 0. So you know that ID1 is Vin minus 0.7 by 1K. So what do you mean by that? ID1 is greater than 0 means Vin is, okay, 1 plus 0.7 is going to be 1.7. Vin is greater than 1.7. And what is V0 here? Your V0 is going to be Vin minus 0.7. So how will you draw the transfer characteristics? It is of the form y equal to mx plus c. So what is the slope m in mx plus c? The slope m is going to be 1. So when you draw the transfer characteristics, above 1.7 volts, the slope is going to be 1, okay? Now what about the other diode? The other diode, D2, again needs a 0.7 volts drop. But mind you, the current direction is in the opposite, right? So if you write a loop equation here, minus 1 plus ID2 into 1K plus 0.7 plus Vin is 0. So what is ID2 here? ID2 is going to be, how much is ID2? It is going to be minus Vin plus 0.3 by 1K. So ID2 is greater than 0, meaning V in should be greater than or V in should be less than 0.3. So let's draw the transfer characteristics here. V in on x-axis, V naught on y-axis. Okay? So for V in, when both the diodes are off, when D1 is off and D2 is off, your V naught is going to be 1 volt. Between 0.3 and 1.7, it's going to be 1 volt. But when V in is greater than 1.7, the slope is going to be 1. When V in is less than 1.7, the slope remains same. So what is V naught here? V naught is going to be V in plus 0.7. Again, this is of the form y equal to mx plus c. So the slope m is still 1. So even if you want, you can substitute here. When V in is 0, it has to intersect at 0.7. So this is the transfer characteristics. I think these are the two simple questions. So one is the op-amp problem and the other one is the diode.
Good evening all GATE aspirants for 2023. I hope you have done very well. And this is Hanmantarao in Electrical Engineering faculty. My subject is Network Theory. Guys, for today's examination under ECE, all the network questions are very easy. You are able to answer within 1 minute. Let me take one by one. The first question is, in a series RLC circuit, the Q factor is given. After the Q factor and resonant frequency is given, and we need to estimate that what are the values of RLC. Guys, for this example, what exactly we need to go for that? If you want to get that RLC 3 values, these are not sufficient. That's why I would like to consider that from the options, how you have to get it that answer, right? Now, according to the options, we need to extract the values of RLC. Now, let me consider that the Q factor. Here the Q factor given, using the Q factor for RLC series circuit. What is the Q factor for RLC series circuit? Omega naught L by R. Now using this omega naught and Q factor, you are able to define that R by L. See this, omega naught by Q. What is omega naught given? 10 power 6 radians per second, and Q given 1000 given. With this we are getting 10 power 3. Guys, from the given options, the ratio of R by L, for which one we are getting 1000, that option is the correct one. If you see that the B option is only one option we are getting, R by L ratio is 1000. See that R value 0.001 by L value is given 1 microhenry, which is 10 power 3. That's why directly you can say that option B is the correct one. This is the direct question. And the next one, let me consider that the maximum magnitude of VR in volts. Guys, this question is given under transient circuit analysis. Without taking calculation, without putting pen, think without ink. In that way, you are able to answer this question. Let me consider that whenever the transient circuit analysis example is given or any question is given,
I have provided the three conditions you need to be checked. The first one is the switching action, second one is energy storage element, the third one is initial value of the inductor or energy storage element is given or not. Here initial value is not given, that we need to get it. We need to extract according to the switching action. As per the switching action, we need to be considered to extract the initial value. We have to consider that history, nothing but before t equal to 0. See that before t equal to 0, switch position is what? It is closed. And inductor is affecting with this. With that, I am able to define that the initial value. Once you close the switch, and to get the initial value of inductor, we need to make under steady state condition of inductor as short circuit. Once you make the short circuit, how much current is passing through that? 2 by 1, 2 amperes is there. And the initial current is 2 amperes, and take that the maximum value of VR at t equal to 0 plus, if you want to get it that, then take the condition at t equal to 0 plus. At t equal to 0 plus, which position is closed? You know that inductor acts as an open circuit with parallel current source. Then you need to replace this one as a open circuit with the parallel current source. I am taking directly at t equal to 0 plus condition. At t equal to 0 plus, switch is open. Guys, you know that whenever the switch is opened, this is not affecting the source. That means you should be consider only this part, which is RL source free circuit. Now under that condition, if you see that, inductor is open circuit with parallel current source. The direction of the current source can be get it from the history value. Here 2 amperes current is passing through that. Here this is VR 0 plus. As per the given polarities of VR, see this is positive and this is negative. Now with this I can say here 2 ohms resistance is there. As per the VR, as per the direction of initial current of inductor, I can say that minus 2 times of 2. But he was given that the magnitude, now VR magnitude, I can take it 4 volts. I think what the answer, what you have to write that, you need to type as 4. Now let me consider the next example. Next question is given, which is related with the, again, transient circuit analysis, but this is the 2 marks question. See guys, this example also you can do it directly. Now, as per the question, the switch is S1 is closed and S2 is opened for a long time. At t equal to 0, switch S1 is opened and S2 is closed. The value of IC of 0 plus. See this, IC of 0 plus is downward direction is given. Here also the same way we can take it, that is, before t equal to 0, this switch position is closed and this switch position is open, and inductor and capacitors are affecting the source. Let me extract the values of initial values of inductor and capacitor. For that, you need to replace that inductor as a short circuit and capacitor as an open circuit. Now by making the capacitor as open circuit, see this one, and inductor is short circuit, here we are getting that the 125 both are parallel. Now to obtain the open circuit voltage, what we need to do that, which is the combination of voltage across 125 parallel. Take that 125 both are in parallel. How much you are getting that? 125 by 125, which is equal to 100 by you are getting 5, which is 20 you are getting. 20 into 1 is 20 volts. Capacitor initial voltage is 20. And what about the 100 amperes current, 100 ohms resistor current, which is short circuit path current? That current is what? Initial current of inductor. By making the short circuit here, this current is equal to by CDR, current division principle, you will get it. Total current into opposite resistor by sum of the 2 resistors, nothing but 1 into 25 by 25 plus 100, which is equal to 1 by 2. That value you are getting 1 by 5 means, which is 0.2 amperes. Now let me take that the initial values of, this is the way how we need to get it directly, initial value of inductor and capacitor. Once you obtain the initial values, IL of 0 is equal to 1 by 5, which is 0.2 amperes, and VC of 0 plus, which is equal to 20 volts. Now let me take that the circuit at t equal to 0 plus. Since we need to get it the value at t equal to 0 plus IC of value, IC of 0 plus. Now let me consider that S1 is opened, S2 is closed. See guys, how we are
developing the network at T equal to 0 plus. Capacitor is short circuit with series voltage source. Getting? And this one is short circuit here. Once the S2 is open, definitely, see this? We are getting, this is what? Open circuit with parallel current source means only current source we are getting. Now this value is 0.2 amperes and this is 25 ohms now. And how all the three elements are in parallel? In parallel, you know that voltage is same, then 20 volts is appear here. This value we are getting Ix, suppose if you consider that 20 by 25, which is 4 by 5, which is 0.8. Now to obtain the value of IC of 0 plus, take KCL at X point. Now by using the KCL, I can get it. By KCL at X. See that all are leaving, that's why I can take it, I can add it all. IC of 0 plus 0.2 plus 0.8 is equal to 0. Now IC of 0 plus value, how much you are getting that? Minus 1 ampere. See the question, this question is given under NAT, numerical answer type. That's why you need to type here minus 1 because given in terms of amperes. These are the questions given and two more questions are there. Let me consider the two more questions. One is given under one more question. That question is, this is very simple question here based on the source transformation. Two volts, 2 kilo. This is 2K, 1 milli, 1 milliampere, 1K. This was given 200 ohms. This is our required value here. How we need to take it that, guys? See this. Only by using the source transformation, I can get it the direct values. Let me consider that here. If you do the source transformation here and here, we are getting that the equivalent of this one is a voltage source with series resistance. That value you are getting that 1 into 2 means 2 volts and 2K in series. Again, I do that source transformation here and also if you see that by using the source transformation again, 1 milliampere upward direction, here 1 milliampere upward direction, both are connected in parallel. Finally, you will get the circuit. Once you simplify this circuit, you will get it. This is 1 plus 1, 2 milliamperes and parallel you are getting 2 and 2 are connected in parallel. 1K you will get it. This value is 1 volt with negative to positive direction and the series resistor is connected 1K with 200 which is 1200 or 1.2K. This is our required value here. If you want to get it that, again I want to take that source transformation. If you do the source transformation here, this is very simple here. You are able to take that directly. Now this one, again, how much voltage you are getting that? This is 2 volts and 1. This is the equivalent one for 1K. Then finally, I can take it that as per this, minus both are there. Now directly, I can say that 2 plus 1, which is equal to 3 by, this is 1K and 1.2, nothing but what? 2.2K. With this, 3 by 2.2 milliamperes we are getting. With this 1.36 or 63, 1.36 we are getting. 1.363 you are getting that milliamperes. Now as per that the answer is here you have to type there answer as 1.36.
3 by 2.2, you are getting that. This is the one more question, and one more question I will take it, which is given two-port network parameters here. This is the 2 marks question, which is very the question is, Y parameters matrix is given. For the input side, it was connected a voltage source with series resistance, and the output side, it was connected a load, that is ZL, given as a ZL here, not RL. It was given that as a ZL, and here Y parameters matrix is given, that is 1 by 100, and here 2 minus 1 and 4 by 3 given. The question is, at what value of ZL maximum power transfer from source to load resistance? Guys, you know that whenever if you want to get the maximum power through the load circuit for the load circuit, first you need to take that entire network across the load circuit as Thevenin's equivalent. Under the Thevenin's equivalent also, as per the question, we need not go for Thevenin's voltage value. We need to extract or we need to find out only R Thevenin's value, because this is a resistance value. That's why if you want to get the only R Thevenin's value, we have to deactivate the independent sources. If you deactivate independent source, see this one. If you deactivate the independent source, this is the independent source. If you deactivate, what you have to get it that the equivalent resistance faced by that output terminals or load terminals. Now this value you have to estimate. Once if you want to get it that Z Thevenin's or R Thevenin's, which is equal to V2 by I2, guys. Now let me define that the Y parameters matrix equations. What are the Y parameters equations? From this, I1 is equal to Y11, nothing but 2 by 100 into V1 minus 1 by 100 into V2. Second one, I2 is equal to minus 1 by 100 into V1 plus 4 by 3 times of 100, 300 into V2. Now from this you have to get it the ratio of V2 and I2. The same we have to take that ZL value to obtain the maximum power in ZL. In these equations, from these two equations, I need to get that value, that ratio. If you want to get it that here, from this V1, I1 relation I can take it by deactivating this independent source. Tell me this, what the relation you are getting for V1 and I1? As per the current direction for two-port network, according to the V1 polarities, I can say that V1 is equal to, what I can take it? Minus 10 times of I1. Get it? Now in the place of I1, if you replace that V1, then definitely V1, V2 relation you will get it. Once you obtain that V1, V2 relation, then that V1 value in the second expression, I can take it in terms of V2. From the second expression, you will get I2 by V2 by I2, which is same as R Thevenin's or Z Thevenin's. Now let me take that the I1 value is equal to minus V1 by 10. See this? I1 is equal to, I should consider that I1 is equal to minus V1 by 10. If you take that minus V1 by 10, here 2 by 100 V1 minus 1 by 100 into V2, you will get the relation between that V1 and V2. Are you getting? Once you obtain that V1 and V2 relation, you substitute the value of V1 in terms of V2. Once you get that, once you simplify that equation, finally you will get the value of V2 by I2 is equal to R Thevenin's, which is equal to, you will get 400 by 5, you will get it, which is equal to 80 ohms. Nothing but at value of ZL 80 ohms, we are getting the maximum power from source to load circuit, right? The answer for this one ZL value is equal to 80 ohms. These are the questions under network theory given. Now I would like to hand over my session to
Control systems are Professor GNR sir.
My name is J. Nageswarav. I am going to discuss the control system questions. So first one, given a transfer function g of s, h of s unity given, here h of s equal to 1. You asked phase crossover frequency. So at omega PC, the angle of g of j omega equal to minus 180. So minus 180 equal to, what is the angle of g of j omega? Minus 90 minus tan inverse of omega tau 1 minus tan inverse of omega tau 2. All minus make it plus, then 90 equal to tan inverse of omega tau 1 plus tan inverse of omega tau 2. So this equal to 90 equal to tan inverse A plus tan inverse B, tan inverse of omega tau 1 omega tau 2 divided by 1 minus omega square tau 1 tau 2. Tan 90 is infinity. Infinity means denominator should be 0. 1 minus omega square tau 1 tau 2 should be equal to 0. Then omega, it is called omega PC, equal to 1 by root of tau 1 tau 2 radians per second. So the answer is A. Second question. Find the steady state error to the given system and the given here ramp input given alpha t u of t. So steady state error for ramp input is ESS equal to A by kV. So simply A is 1 given. So ESS, A is given alpha, this is called A. A given alpha. Alpha. K is called simply numerator constant by denominator constant in G of S. Numerator constant is K divided by denominator constant is 2. So simply 2 alpha by K. The answer is 2 alpha by K. Next question. They given a Bodo plot. Magnitude. This is omega 1. Omega 2. Minus 20 dB for decade. Here minus 40 dB for decade. They given G of S, transfer function given, K into S plus 2 whole power A by S power B into S plus B whole power C. They asked ABC values. The initial slope gives the what? Poles and zeros at origin. Initial slope is minus 20. Minus 20 means one pole at origin. That means it is nothing but 1 by S power 1. That means, so B equal to 1. This is nothing but B. So B equal to 1. Then if you find here change in slope, what is the change in slope? Plus 20. That means I can write it as 1 plus S by omega 1. So plus 20 means whole power 1. So that means if you compare here, this is a 0. So here 0 is 1 plus 2 whole power A given. So A value becomes 1. A is what? How many zeros? 1 0 na? 1 0. So A equal to 1. Then here find again change in slope. It will become minus 40. Minus 40 means 2 poles. 2 poles means like 1 by S plus like omega 2 we can take. So 2 poles means square. That means C equal to 2. So A1, B1, C equal to 2. Last question. They given a block diagram. R of S D of S. So they given C equal to G1 into R plus G2 into D. They asked what is G1 and what is G2 they asked. So simply find C by R, then you will get the G1. So C by R equal to, so consider D of S 0. Then the forward path gain is simply G by 2 loops are there. This is loop 1, this is loop 2. So 1 plus GH plus G. So this is nothing but G1. This is nothing but G1. Next find C by D. So forward path gain G divided by, so 2 loops same thing, 1 plus GH plus another loop G. This is nothing but G2. So G2 is G by 1 plus GH plus G. So next Chakrapani sir, Professor Chakrapani sir will continue digital.
Yeah, let's have a look at the questions appeared in digital. They are of moderate difficulty. Let us see what's the solution for this. First one, 2 D flip-flops are connected like this. In this circuit, the clock frequency is 1 megahertz. Then it's asking what is the output frequency. For this, we have to see after how many clock pulses the sequence is going to repeat. Okay, so for that, we are going to write it like this. Initially, both outputs are 0, 0. So compute the values of D1 and D2, and you know the nature of D flip-flop. For every clock pulse, the D input goes to the respective outputs. So D1 is Q2, 0, and D2 is Q1 bar, 1. So on application of first clock pulse, this values goes to the output, to the respective outputs. And then again, using these equations, fill this. D1 is Q2 and D2 is Q1 bar, that is 1. Apply the second pulse. Same thing here. D1 is Q2, that is 0, and this is D2 is Q1 bar, that is 0. That's it. That means the sequence at the output is repeating after every 4 clock pulses. That's the reason output frequency is clock frequency divided by 4. Clock frequency is given as 1 megahertz divided by 4. This comes to 250 kilohertz. That is the answer to this question. Problem number 2. For this given shift register, is asking what is the latency and what is the throughput. We know that latency is nothing but time taken to fill the shift register with all the bits. Okay, whatever input bits I'm giving here, they should go and reach to Q1, Q2, Q3. Whatever time is taken for that, it is going to be called latency. And throughput means how many number of bits per second you can transmit at Q3 output. So these are the two things. Obviously, suppose if I want to fill 101. So for this value to reach to Q1, Q2 and Q3, I need to apply 3 clock pulses. I need to apply 3 clock pulses. That is, after 3 clock pulses, this will be 1, this will be 0 and this will be 1. So that means the time taken for this is 3t. And the clock frequency is given as 1 gigahertz, that means t equal to 1 nanosecond. So that's the reason this is nothing but 3 nanoseconds. And next one, what is the throughput at the output? Obviously, for every 1 clock pulse, 1 bit will come out. That means for every 1 nanosecond, 1 bit is coming out. So how many number of bits you transmit per second? It's nothing but 1 by t. That is 1 gigabits per second. So that is the throughput of this particular circuit. So from my side, the final problem is a ADC is given and its signal to noise ratio is equal to 61.96 decibels for sinusoidal input. Find percentage resolution. You know, to calculate the percentage resolution, I have to know the size of the A to D converter. How many bit A to D converter? Because its formula is 1 by 2 power n minus 1 into 100. So for that, little bit of PCM concepts you have to use here. For a sinusoidal input, the signal to noise ratio is given by the formula 1.76 plus 6n. Okay, so that is 6n is going to become 60.2. So n is approximately 10 bits. That means it is a 10-bit A to D converter. Thus, the percentage resolution is equal to 1 by 2 power n minus 1 into 100. That is 1 by 2 power 10 minus 1 into 100. So this is approximately 1 by 1000 into 100 comes to 0.1% resolution. That is the resolution of the given A to D converter in terms of percentage. In terms of number of bits, resolution is 10 bits. Now I request my colleague, Professor Y.V. Ramaya sir, to come and finish the other problems.
This is Y.V. Ramaya. Already our respected checkpointers have discussed 3 questions. I am going to continue the same digital subject for 2 more questions. First one, it is simple question. Pen and paper are not required. Only 3 to 4 seconds time is sufficient to solve the question after completion of reading. It is our multiplexer. First of all, it is I0 input and it is I1 input. I1 input is connected to variable A. I0 is connected to ground directly at the same time. Select line is connected to B. It is Y. He asked the functional expression at Y. Options are like this. Given options are like this. A plus B, AB, AB whole bar, A plus B whole bar. He asked the output expression at Y. Simple expression, simple solution. I0 input is nothing but ground, that's why. When B is 0, I0 will be selected to Y. Since it is 0, output is 0. When B is 1, I1 will be selected, means nothing but A into B. Correct answer, option B. And in detail, it also takes only 30 seconds time. Now look here. Select line is nothing but B, output is nothing but Y. If B 0, output is nothing but 0. B1, output is nothing but A. So SOP expression is nothing but B into A, nothing but A into B. Simple question it is. Next. Watch the diagram carefully. In this, he mentioned each NAND gate delay is 1 nanosecond, and the question is, the critical path delay is dash nanosecond. It is nothing but a latch. Inputs are AB. These are outputs. Each NAND gate delay is 1 nanosecond. So in this case, already we know NAND gate. If any one of the input is 0, output will be forced to 1. Suppose initially, let it is 0 and it is 1. Assume like that. Then watch the diagram carefully. These are the inputs and it is the delay, time delay. Now, let inputs are 0. A is 0, B is 0. Look here. Here Q output is connected as the second input, first input for the second gate. At the same time, Q bar output is connected as the second input for the first gate. That's why when it is 0, it is 0, it is also 1. Now, if you apply 0, 0 here 0, zero. Here, this 0 changes this output to 1. To change this output, it has to complete this NAND gate delay, means 1 nanosecond plus. After this 0 becomes 1, but because of this 0, it does not make any change at the output. So that's why its delay is 0. So finally, longest delay is 1 nanosecond. Now, if you apply 0, 1, 0, it is 1. In this case, take initial outputs 0, 1 only. Now in this case, to change, only this 0 input is sufficient to change this 0 to 1, means it takes 1 nanosecond. At the same time, automatically after changing this one, this input will be changed, means 1, 1, this output will also be changed, not immediately after completion of this gate delay, because in this, for this input, these two act as series circuit, that's why 2 nanosecond. If you apply 1, 0, look here. Excellent question it is. Initially, outputs are 0, 1. Now we applied 1, 0 input. Already this 1 is available here, this 0 is available here. Then it is 1 and it is 1, means it is 0. Earlier it is also 0. That's why additional delay is not needed for this. At the same time, only this 0 input is sufficient to force this output. Okay. Then already it is 0. Already earlier it is 1, means it is nothing but 0, 0 nanosecond. Next, if you apply 1, 1, look here, if it is 1 and it is also 1. Now it is 1 and it is 1, it is 0. Means since there is no change here, this output is also unchanged. Now, not needed to consider. Also in this, longest delay is 2 nanosecond. At the same time, if you take the initial outputs 1, 0 in the place of the same, then also we get longest delay 2 nanoseconds. So our answer is 2 nanoseconds. Next, our professor, Sarwan sir will occupy this.
First question. So what he's saying is he is considering two signals, x1 of t and x2 of t, band limited to 4 pi into 10 cube radians per second. So basically here, be very careful, the axis is given in terms of radians per second. So x1 of t is a baseband or a band limited signal whose transformation is x1 of omega. And he is saying that this is a band limited to a frequency of 4 pi into 10 cube radians per second. So basically you can assume its spectrum taking this form. So because it's a baseband or a band limited signal, I am assuming it in this particular triangular format. So minus 4 pi into 10 cube to 4 pi into 10 cube. Now x-axis is omega. He did not talk anything on peak amplitude, so you can assume it as 1. So this is your center point 0. x1 of t and x2 of t both are band limited to 4 pi into 10 cube radians per second. So both the signals are having the same spectrum. So whether it is first one or second one, both are band limited to this particular frequency. Now he is giving this system to this function to this system. So what is he saying here is, he is taking x1 of t here and multiplying it with a single tone signal, which is cos 4 pi into 10 cube t. So this is a simple multiplier here. So let us assume the output of this multiplier is some y1 of t. So what will be your spectrum of y1 of t? Your original spectrum will shift right and left side by 4 pi into 10 cube. So what will happen? You will have your spectrum shifted right side and left side by 4 pi into 10 cube. So what will be the spectrum that we can show here? When you shift the spectrum right side by 4 pi into 10 cube, this comes at 0 and this comes at 8 pi into 10 cube. That means we will have the spectrum centered about 0, and this becomes 8 pi into 10 cube, and this value will be minus 8 pi into 10 cube. And these peak amplitudes will get divided by 2, so it becomes 1 by 2. So this is your y1 of omega. Okay, and on the other side he is taking the same signal x2 of t whose spectrum is same as x1 of omega, but now he is multiplying with a single tone signal which is given as cos 12 pi into 10 cube t. Okay, 12 pi into 10 cube t. So what would be the resulting signal y2 of t here? Its spectrum means your original signal spectrum, whatever we have drawn here, will shift right and left side by 12 pi into 10 cube. So what will be the resulting spectrum that we can show here? So when you shift that spectrum right side by 12 pi into 10 cube t, so you will have this triangular function, 0 will come at 12 pi into 10 cube, this becomes 16 pi and this becomes 8 pi. That means I will have my spectrum like this. Both shifted right side and left side by 12 pi into 10 cube. So this center value is 12 pi into 10 cube. This becomes 8 pi into 10 cube, and this value becomes 16 pi into 10 cube. Peak amplitude would be 1 by 2. Same thing also happens on the left side. Minus 16 pi into 10 cube to minus 8 pi into 10 cube. So this is a resulting spectrum which I am getting at the output of the second multiplier. Okay. Now what is he doing? He is giving it to a simple summer. He is doing addition here. And he is saying the output is y of t. So what would be the resulting spectrum of y of t? Y of t will have a spectrum y of omega. Your final spectrum looks like this. So I will have these two triangular functions, because when you are doing in time domain addition, it is again time domain addition in time is again addition in frequency. So you will have these two triangles coming here. Okay, I am drawing only on the positive side. Same thing also happens on the left side. So your x-axis is omega, this is 0, this is 8 pi into 10 cube here, and this becomes 16 pi into 10 cube here. And these peak amplitudes will be 1 by 2, also 1 by 2. So this is my spectrum y of omega, which I am drawing for omega greater than 0. Same thing also comes on the left side. Now what is the question he asked? What is the sampling frequency for the signal y of t? Minimum sampling frequency means Nyquist frequency. So basically what would be your type of signal? The most common mistake that you might have done, thinking that it is representing a band pass signal. Be very careful. Here what is the value of fh or omega h? Axis is in omega plane, so it is like 16 pi into 10 cube radians per second. And what is omega L? 0. That means the ratio of this highest to lowest frequency is very, very high. So whenever the ratio of this omega h to omega L is very, very high, then these type of signals comes under band limited signals only. I told this very clearly in classes also. Major difference between band limited and band pass signals. So when you have a band limited signal with you, what is a Nyquist sampling frequency? It will be 2 into maximum frequency of the given signal. Now your given signal is in omega plane, keep it in omega plane only, your options are given in omega plane. So what would be your answer? Your Nyquist sampling frequency or minimum sampling frequency would be 32 pi into 10 cube radians per second. That's all. This is your final answer. So this is how you have to solve the question. It's a very simple question only, not very complicated. Things is basic point, that band limited signal you have to identify it correctly. Right. Let's move on to the next question. Next question is pretty simple question, it's a 1 mark bit. He asked which of the following represents a valid power spectral density. Valid power spectral density. Now these are the options he has given. I am just keeping these options. This is the first one. So he has given a rectangular function here from 0 to 1, again from -1 to 0. So this value is like 0, from -1 to 0 amplitude is -1, from 0 to 1 he has mentioned amplitude as +1 in omega plane. So this is like first one, Sx of omega. And in option B also he has given a figure where he is showing this power spectral density like a step function from 0 to 1. X-axis is omega, amplitude is 1. And C has given an equation. He is saying Sx of omega is e power minus omega square. And last option D is also an expression, Sx of omega is given as 2 by 9 plus omega square. So these are the options given. Now which one is a valid power spectral density? You know, first property of power spectral density is it is an even function. So first one you can eliminate, it is representing an odd signal or not. So simply you can eliminate it. And second one you can see this is neither even nor odd. Fundamental of signal. So you can also eliminate this. Now if you replace omega in the expression with minus omega, this becomes again e power minus omega square. That means this is representing an even function only. So definitely this can be correct. And check for the last one also. If you replace omega with minus omega, you are again getting 2 by 9 plus omega square. So this is also representing an even function. So this is also correct. Along with this, what are the other properties? It should be real as well as even. So even we have checked, definitely both functions are real. There is no complex term present here. So both C and D are correct. It's a multiple select question. But as far as I am thinking, it is just like 1 mark bit. So we don't know the exact weightage given to the question, but pretty simple, straightforward bit. Let us see one more question. So this is given on response of LTI systems. response of LTI systems to random process. So the data given is, he is saying the power spectral density of the input function. So there is an input autocorrelation function Rx of tau, for which the power spectral density is given to you as 1/2 watts per hertz for all frequencies. That means what is the meaning? You are having a constant amplitude of 1/2 from minus infinite to plus infinite. This is how we can represent power spectral density of input random process. Now he is giving this as an input to an LTI system. So what is the LTI system given? H of t is given to you as e power minus t u of t. So what would be its system function h of f? Fourier transformation is 1/1 plus j into 2 pi f. So what would be mod of h of f whole square? This would be equal to 1/1 plus 4 pi square f square. Finish. Now definitely you will have an output power spectral density. So there will be an output autocorrelation function I am writing as Ry of tau, for which output power spectral density is Sy of f. So what is the relation we have? Sy of f is equal to Sx of f multiplied by mod of h of f whole square. So what would be this Sy of f now? Input power spectral density is 1/2 multiplied by mod of h of f whole square is 1/1 plus 4 pi square f square. Now very important observation here is you have to fix the limit of integrals, or from where to where your frequency is coming. This is valid for all frequencies. This is also valid for all frequencies. So whatever output you are getting has values from minus infinite to plus infinite. So what would be the output power? That is the question he asked. What is the power of the noise coming at the output of the system? So this is nothing but total area under your power spectral density function. So this will be, I am writing 1/2 outside, limits will be from minus infinite to infinite, 1/1 plus 4 pi square f square df. Now if you simplify this value, you will get this value as 1/4. I think its value will be 0.25, a simple integral value. You can write 2 pi f whole square, take some parameter y, just do the integration, you will get its value as 1/4 or 0.25. So these are 3 memory based questions that I have received from communication point of view. I am assuming that this question is given for a 2 marks, and first question we have seen is also a 2 marks, second bit is like 1 mark. Remaining questions I haven't received. As far as the paper which we got the input from the students, I think around 9 or 10 marks have come from the communication systems. So once I get the remaining, we'll upload the remaining questions. My colleague will take the next part from here on. Thank you very much.
Hi, myself P. Venkatrao. Now we discuss the questions which we were given from engineering mathematics. So one of the question that we were given from vector calculus, the value of the line integral, the value of the line integral z square dx plus 3y square dy plus 2xz dz. We were asked to find the integration value along the straight line from P 1, 2, 3 to Q 2, 3, 1. We were given 4 options. One is 24, another option 29, one option 20 and one option 12. The points P1, 2, 3 and Q2, 3, 1. And you observe most of the questions when you observe regarding line integral, most of the questions we were given in the gate examination which must be related to exact differential. Means it should be written as derivative of some function of xyz directly. Look at this expression, and we were asked to find the value of the integral from 1 to 3, upper limit is 2, 3, 1. Observe the first and last terms here, z square dx plus 2x z dz. It's an exact differential. Just observe this. It should be derivative of xz square. Observe that derivative of xz square, derivative of UV rule, z square into dx, next x into derivative of z square, differential of z square is 2z dz, 2z dz into x plus 3y square, plus 3y square. Integration of derivative of xz square is simply xz square, this is xz square, xz whole square, sorry xz square, plus integral 3y square dy is y cube between the limits 1, 2, 3 to 2, 3, 1. Simplify this expression, substitute x equal to 1, z equal to x equal to 2, z equal to 1 and y equal to 3. This value of the line integral should be, observe that x value 2, z value 1, 2 into 1 square 2. Next y value 3, 3 cube 27 minus here x value 1, z value 3, 1 into 3 square 9, y value 2, 8, 2 cube 8. So therefore answer 12, 29 minus 17, that is 12. And one more question from vector calculus itself. So the question is the rate of increment of the function f of xyz. The rate of increment of the function means the rate of change of the function f of xyz equal to xyz. We were asked to find the directional derivative of f of xyz at the point 0, 2, 1, at the point 0, 2, 1 in the direction of a vector. In the direction of a vector v 2, 1, 2. So we have to find the directional derivative of f of xyz at that point in this direction. So simply to say, so better to find gradient first. So how to calculate gradient of given scalar point function? I into given function derivative with respect to x partially plus j into given function derivative with respect to y partially, that is xz into j, plus k into given function derivative with respect to z partially, so that is xy into k. But do you people know we just need the maximum, the directional derivative means the differentiation of the given function at the point 0, 2, 1. So at 0, 2, 1, what would be the value of gradient? X is 0, y to z1, so it is 2i, x is 0, this is 0, x is 0, that is 0. Simply that would be the gradient. But we want gradient in the direction of the point 2, 1, 2, in the direction of 2i bar plus 1j bar plus 2k bar. So therefore, the directional derivative would be 2i bar in the direction of 2i bar plus 1j bar plus 2k bar. in the direction of 2I bar plus j bar plus 2k bar divided by denominator magnitude of this vector, that is square root of 2 square plus 1 square plus 2 square, that is 3. So I dot I 1, therefore it is a 4 by 3 would be the answer. This is the directional derivative of the given function at the specified point in the direction of the vector 2I bar plus 2j bar plus 2k bar. So the paper is moderate, and we see one more question that was given from complex variables regarding the, as we all know, every year we will be given a question from complex variables, mostly from Cauchy's integral theorem, Cauchy's integral formula, or Cauchy residue theorem. What would be the value of the integral? The value of, observe this, the value of integral z plus 2 by z square plus 2z plus 2 dz, where C is magnitude of z plus 1 minus 3z 3 j by 2 equal to 1. And we were asked to find the value of the integral along the specified path. And do you people know, first of all, what is the center of the circle? Minus 1 comma 3 by 2, minus 1 comma 3 by 2. So just to draw a circle, this is just rough diagram only. Whose center at? Just observe this. Center of the circle at minus 1 comma 3 by 2. Center of the circle at minus 1 comma 3 by 2 and radius 1. If radius 1, then it should be 0 comma 3 by 2. If radius 1 from here to here radius, from here to here radius, if radius 1, then it should be minus 1 comma 1 by 2, because radius is 1. Therefore, this is the, from here to here also radius 1, therefore it is minus 1 comma 5 by 2. But first of all, we have to find the singular points. This is the curve of z plus 1, magnitude of z plus 1 minus 3j by 2 equal to 1. A circle whose center at minus 1 comma 3 by 2 and radius 1. And observe that this. Now, what are the singular points? Singular points of the given function. Z square plus 2z plus 2 should be written as z plus 1 plus I, it should be written as z plus 1 minus I. It should be written like this. Therefore, what are the singular points? Singular points are z equal to minus 1 comma minus I, that is minus 1 comma minus 1. Minus 1 comma minus 1, you observe this, it lies outside. Minus 1 comma minus 1 lying outside. And moreover, another singular point is minus 1 plus I. Z equal to minus 1 plus I, it should also be written as minus 1 comma 1. You observe this, everyone, this is minus 1 comma 3 by 2, this is minus 1 comma 1 by 2, this is minus 1 comma 5 by 2. So therefore minus 1 comma 1 somewhere between minus 1 comma 1 by 2 and minus 1 comma 3 by 2, this. So only the singular point minus 1 plus I, that is lying inside the curve. Another singular point lies outside the curve. Therefore, we need to solve this problem using Cauchy's integral formula, or it should also be solved using Cauchy residue theorem. I think integral formula is comfortable. Suppose if you wish residue theorem is fine, you can apply even residue theorem as well. Now, this integral z plus 2 by denominator, it should be written as z plus 1 into z plus 1 plus I into z plus 1 minus I into dz. This is equal to one singular point lying outside the curve, therefore it should be written as z plus 2 with singular point z equal to minus 1 minus I, or you can write minus 1 minus j or minus 1 minus I. It doesn't matter whether you can write it as I or j. Of course, initially have written j here. If you want, you can make it as I. It doesn't make a sense. So therefore it is, I will write this in the numerator z plus 1 plus I, or you may write it as j as well. C, denominator z plus 1 minus I should be written as z minus of I minus 1, z minus of I minus 1 into dz. So as per Cauchy's integral formula, what is Cauchy's integral formula? Integral f of z by z minus z naught dz. How much it is? 2 pi I or 2 pi j into f of z naught, f of I minus 1. What is f of I minus 1? Let this entire function be f of z. Let this entire function be f of z and simply substitute over there, you will get the answer. This is equal to 2 pi I or 2 pi j, substitute f of z, z means I minus 1, therefore it is I minus 1 plus 2, denominator I minus 1 plus 1 plus I, and observe this carefully. You observe this minus 1 plus 1 cancel, and moreover I plus I, 2i, this 2i cancel. Therefore what we have, pi into, the final step is pi into I plus 1. The remaining 2-3 problems were given. The remaining 3-4 problems will be taught by my colleague Dr. Manikumar. He will take over the session now. Thank you.
Welcome back, students. I am Dr. Manikumar. I am here to discuss remaining problems of mathematics based on memory. Linear algebra. Actually, two vectors. From the student memory, we have got an information like this. That is, V1 is equal to 1, 2, 0. This is one vector. And V2 is equal to another vector is 2, 1, 3, given like this. And V1 is equal to, it was given as V1 is equal to alpha V2 plus E, where E is some error or something given. The value of alpha, question is the value of alpha for which minimum length of E. Length of E is minimum. Question is given like this. E should be minimum. Okay. To get the minimum value of E, what value of alpha E is minimum. Okay. That is we are asking here. Now coming to the solution. What is given here? You see solution. One information given. E actually we have to make E is as small as possible. That is nothing but E is equal to, from this given data, V1 is equal to alpha V2 plus E given. So E is equal to V1
my students, a small technical issue, just now it was resolved. Now, coming to continuation of the solution, actually we have to find the minimum possible value of E. For that you can write from the given condition, V1 is equal to alpha V2 plus E. You can separate E from it. E is equal to V1 minus alpha V2. What is V1 here? V1 is nothing but 1, 2, 0 minus alpha into what is V2? 2, 1, 3. Now, what it is? This is 1 minus 2 alpha. This is 2 minus alpha. Next, minus 3 alpha. Length of E is minimum, not E. Length of E we have to make minimum. So what is length of E? Length of E is nothing but norm E, that is root 2 over, okay, this is 1 minus 2 alpha, this is a column vector, 1 minus 2 alpha whole square plus 2 minus alpha whole square plus of minus 3 alpha whole square. Is it? Now you simplify it. If you simplify, what you get here? That is nothing but this is 1 plus 4 alpha square minus 4 alpha plus 4 plus alpha square minus 4 alpha plus 9 alpha square will get. So what it is, what is the next step? That is 14 alpha square minus 8 alpha plus 5. So norm E means length of E is nothing but root over 14 alpha square minus 8 alpha plus 5. It is a function of alpha, let it be f of alpha. Now we have to make this length is the minimum. For that, this function you have to make minimum using maxima and minima concept. Okay, so put f dash of alpha is equal to 0. Put f dash of alpha is equal to 0. Means we have to find a stationary point by taking f dash of alpha is equal to 0. So what it is, f dash of alpha is equal to 0 means find the derivative of f of alpha. Root x derivative is 1 by 2 root x or not? Root x derivative is 1 by 2 root x, that is 1 by 2 root 14 alpha square minus 8 alpha plus 5, okay, into again 14 alpha square minus 8 alpha derivative is 28 alpha minus 8 is equal to 0. We have to make it as 0. So complete after cross multiplication, complete denominator becomes 0. Now coming to only numerator part, that is 28 alpha minus 8 is equal to 0. 14 alpha minus 4 is equal to 0. That implies alpha is equal to 4 by 14. It would be 2 by 7. 2 by 7 is the answer for this question. Okay. Now coming to the next question. Coming to the next question is available. Here it is like this. Now, a question is given like this. Which of the following one function given to you like this, one graph given. One graph given like this. 4 functions given, 4 options, 4 functions given. Function, okay, first of all, in first option, f of x is given as x 2 power minus x. In option B, it was given as x square 2 power minus mod x. Option C, it was given as mod x e power minus x. Option D, it was given as x 2 power minus mod x. See, this, which of these following function represents the above graph? Very clear. This graph is, you observe that graph clearly, that graph is symmetric about y-axis. Graph is symmetric about y-axis means no doubt that function is an even function. Okay, which of the following is even function you verify? Luckily, if only one option is even among the 4 options, that would be an answer. No need to verify remaining. So very clear, verify option B here. Option B is even function. What is even function definition? You know, if f of minus x is equal to f of x again, that is even function. Among the 4 options, okay, only option B is the even function, remaining all are not even function. So very clear that given graph, see, in option B, the function represents the given graph. So which option is right? Option B is correct. Now coming to the next question. One vector capital X is a column vector given is n by 1 column vector. Like that it was given like this. Column vector, and L is equal to root 2 over X transpose into X given. X transpose into X given. Now the question is trace of, based on students' memory, question is like this. X into X transpose. Trace of X into X transpose is equal to what? Okay, 4 options are available here. That is L square by 2. Option B is L square. Option C, L square by 4. Option D, L. Okay. Now coming to C. This type of question you can take n cross 1 column vector means actually I have to take n elements in the column. But don't take like this. So instead of taking n elements, simply I will take a simple example just with 2 elements only. Just a 2 by 1 column vector only I will check. Which option satisfies, that I will verify. You can save your time by doing like that. Now coming to the solution. Consider solution. Let x is equal to, just instead of taking n by 1, I am taking just a 2 by 1 only, 1, 2. Consider a vector, this is 2 by 1 matrix. 2 by 1 column vector. Then what is X transpose? What is X transpose? This is 1, 2. This is 1 by 2. Now, what is X transpose into X? X transpose into X, length of X, L is nothing but the length root of X transpose into X. What is X transpose into X? That is 1, 2 into 2, 1. What it is? This is 1 by 2, 2 by 1 means 1 by 1 matrix, you will get what it is? 1 into 2, 1 into 2, 2 plus this is 1, 2, 2, 1. This is nothing but 1 into 2. Just a minute. X transpose into X means this is like this. Sorry. Now this is nothing but 1 plus 4, 5. We'll get 5. Now what is L here? L is nothing but root over. L is equal to root over X transpose into X. Root over X transpose into X means root over 5. Is it right? Now what is our question here? Our question is nothing but, you see, X into X transpose trace. Now you take X into X transpose matrix. X into X transpose matrix you take now. Now X into X transpose. What is X? Actually X is given as 1, 2. Into X transpose is nothing but 1, 2. This is 2, 1, sorry. 1, 2, okay, this is 1, 2, okay, right. This is 1, 2, 1, 2. Now, you will get a 2 by 2 matrix here, 1, 2, 2, 4, is it? You will get a 2 by 2 matrix like this. Now, what is trace? Trace of X into X transpose. Trace of X into X transpose is nothing but sum of the principal diagonal elements, that is 1 plus 4, that is 5. What is 5? 5 is nothing but, see this, L is nothing but root 5. 5 is nothing but L square or not? So, X into X transpose is equal to L square. X into X transpose is equal to L square. Which option is right? Option B is correct. Okay. This is X. Okay. Okay. These are the 4 questions. Remaining 4 questions on mathematics as per student memory. Now, next our aptitude faculty, Hemant sir will discuss the questions on aptitude problems.
Hello my dear friends, let us go ahead with numerical ability questions, solutions. We got around 4 questions from our students, so we'll discuss those 4 questions dear. So this is the question they are asking regarding how many rectangles are there in this given figure. So the same question is actually given in electrical also. They asked for triangle, but now for electronics they asked for how many number of rectangles in the diagram, right? So guys, if you just go through, okay, number of rectangles, okay, we're given a shortcut rule like, okay, how many rows, how many columns? I have 3 rows, okay. Among the 3 rows, you need to select 2 rows because for one rectangle, 2 rows and 2 columns required. So among 3 rows, I have to select 2. Among 3 columns, I have to select 2. 3C2 into 3C2, which is 3 into 3, 9. So what is this 9 is actually from this point. That 9 is counted from this. I taken that 9 focusing on this 9, okay, rectangles from this diagram. Okay, this is rhombus shape. You can just tilt it. We will get a rectangular square shape here. Fine, we got 9 from that. Square also counted as a rectangle for information. A square is a rectangle where length equal to breadth. Okay, and here this entire here, that's what now. See, this is square. This is also counted. This big square also counted as a rectangle only. So 9. Already plus 1, this big one, plus 1, we got totally 10 rectangles in this given diagram, my dear friends. Right. Now see the next question. Yeah, Venn diagram related. Okay, they given expected questions only. We generally expect Venn diagram or syllogism questions. From counting figures also we can expect the question that comes under spatial aptitude or visual reasoning. Right. Now here see this. In a class of 100 students, there are 30 students who neither like romantic movies or comedy movies. Out of 100 students, okay, total area is 100. Total area is 100 we can consider. Among the 30 people are not belonging to these two, which is romantic movies and comedy movies. 30 people don't like those two. And they given other information. Number of students who like both is 20. Number of students who like both romantic movies and comedy movies, both is 20. Okay, both is 20. Right. So guys, total area is 100. This romantic and comedy should be 70 because out of 100, 30 gone already. This should be 70, my dear. So this too should be 70. Already 20 gone. Out of 70, 20 gone, then 50. This only romantic, only comedy. This is only romantic area. This is only comedy area. These two summation must be equal to 50. Out of 70, 20 gone. So these two summation must be equal to 50. They given here romantic movies total romantic movies, we can say a romantic, they didn't mention only. If they use the word only, then that is this area. They mention romantic is twice the comedy movies. Romantic is twice the comedy movies. Okay, you can take this is A and B. Romantic is totally A plus 20, you know. Romantic means total value of the entire circle, that is A plus 20. Comedy is nothing but this entire total circle value 20 plus B. As per the question, romantic is nothing but equal to twice the comedy. How many are watching that romantic movies is twice the comedy. So we can say A plus 20 is nothing but twice this. We got 40 plus 2B, right? So, and here we have the idea, it's A equal to 2B plus 20, we can say. A equal to 2B plus 20 is one thing. The other one here I just now given, A plus B must be equal to 50. Total this is 70. Here 20 gone, A plus B must be equal to 50. So A plus B equal to 50. A equal to 2B plus 20. In place of A, we can substitute 2B plus 20. Then 3B plus 20 equal to 50. Okay, 3B equal to 30. If you just work on it, okay, B value 10 will get, my dear friends. B value will be 10. B will be equal to 10 finally. Okay, when you got B value 10, A will be equal to 40. This is 40 and this is 10. Okay, now question is, what they are asking? Romantic movies. They asked only romantic means 40. See, only romantic is 40. They are asking romantic means A plus 20. So guys, if you just calculate A plus 20, hope you got it's 60, right? So A value already 40. You have 40 plus 20, we got 60 is the answer. Right, option A is correct. Related to Venn diagram, two different varieties, variables are given. We can do it easily. Now see the next question. Read the question carefully. This is a basic question. Okay, here we have to see smallest number with distinct different digits. Distinct digits. Digits should not repeat. Here if you observe this question, 5s are repeated, directly eliminated. Here 9s are repeated, directly eliminated. First with the word distinct digits. Okay, two options eliminated. Sir, fine, okay, then what's the other thing? See here, sum must be added up to 45. Sum of the digits must be equal to 45, right? Smallest one. So among these two, okay, 5, 6, 7, 5, 7, 8. This is 5, 6, 7, 5, 7, 8. 5, 6, 7 is smallest. 5, 7, 8 is bigger one. And here sum of these digits, it's sum of natural numbers up to 9. So n into n plus 1 divide by 2, hope you got 45. So that is also satisfied. Sum of digits must be added up to 45. Okay, and it should be different digits, is all different digits available in B and D. D also will give sum of digits 45 only, because 1, 2, 3, 4, 5, 6, 7, 8, 9 all available. They are asking smallest. So to satisfy that smallest, we have to go with option B, right? See the next question, my dear friends. So this type of question, if you see in GATE 2021 papers, okay, video solutions already available in our YouTube channel. Okay, we given already similar questions. GATE 2021 questions are there. Okay, similar to that, they given this question. Okay, 10 centimeter by 32 centimeter rectangular sheet. So let's take a rectangular sheet here, which is 10 by 21. Yes, I find, let's consider this is 10 centimeters by 32 centimeters rectangular sheet. Okay, where length is more, okay, breadth is less, 10 by 32, fine. Is folded 5 times. Okay, after folding it 5 times, okay, what they said, each time the folded, the long edge aligns with its opposite side, fine. And eventually, finally, the rectangular dimension should be 10 centimeter by 1 centimeter. Clearly, length is not changing. Length is not changing, only breadth is changing, right? Now, you have to fold 5 times. Okay, 10 centimeters with 32 centimeters. You should get 10 centimeters by 1 centimeter. You are folding 5 times. Now, they are asking total number of creases. See, crease is formed when you fold the paper. Okay, now just I folded 1 time. This is the paper, I am just folding it 1 time. Okay, so now if you fold 1 time, Okay, this is the line. A line formed by folding a paper is called crease. This is the crease we can call. So when I fold one time, one crease I got. Okay, one time. But how many times you have to fold? 5 times, right? One time I got one crease. Don't say 5 times 5. It's not 5 answer. Many people will go with that wrong perception. Wait, let's see about next fold. One folding, I got one line here. Next I'll fold one more time. 2 times, then what will be the result we'll see. So second time I am folding. When we fold the paper second time, okay, I fold it. Now we'll open and we'll see how many crease are there, crease lines are there. Now if you see, this is 1, 2 and 3. We can find 3 lines formed due to this folding 2 times. So 1, 2, 3. 2 times I got 3. This is actually 2 square minus 1. I'll go for one more time. Third time also. You can observe 7. Okay, now I'm doing third time folding. Third time folded. So now 3 times I folded. Okay, I'll open, I'll show you. 7 is there. I folded 3 times. Now I open the paper, that rectangular sheet. You can count how many creases are there is 1, 2, this is 3, this is 4, 5, 6, 7. 7 crease lines are formed. 7 crease lines are formed when I folded 3 times. So for 2 times we are getting 3. 3 crease lines are there when you folded 3 times. This is actually 2 square minus 1. When you fold it 3 times, we got 7, which is nothing but 2 cube minus 1. When you fold it 5 times, you will get 31, which is 2 power 5 minus 1. Right, so 31 is the answer, my dear friends. We got around 4 questions data from our friends, so that's what we explained here. Once all questions were received, within a week, okay, anyhow, okay, once this all exams are completed from GATE, they'll anyhow release the paper along with the key. We'll have a further discussion when all questions will be obtained, right? So please wait for a few more minutes for EMI discussion. Thank you.
Okay friends, let us see the questions which are related to the electromagnetic theory. A very sizable weightage is given in this year related to this subject. Okay, I am getting some information, it is around some 12 to 15 marks are dedicated for this subject. Let us see the solutions of the questions what we have collected so far. So consider a narrowband signal propagating in the lossless dielectric medium. Here it is a lossless dielectric medium. So lossless dielectric medium is a non-dispersive medium. So in the non-dispersive medium, we know that beta is proportional to omega. So if the beta is proportional to omega, phase velocity is equal to group velocity. How do you find out the phase velocity? Vp is equal to 1 by square root of it is the lossless mu naught epsilon naught into epsilon r, which is equal to C divided by square root of epsilon r. So the Vp is equal to, it is C divided by square root of epsilon r is a 4. So a phase velocity is less than C, fine. And for the non-dispersive medium, phase velocity is equal to group velocity. You can also say that this is equal to group velocity. Okay, it is not a dispersive medium, it is a non-dispersive medium. So what you can say that the phase velocity is less than C and the group velocity is less than C. Fine. So the phase velocity is less than C and group velocity is also less than C. Option B is answer. Fine. So let us take one more question. So this question was related to the polarization concept. Okay. So let me do one question, one thing, and from there let us try to obtain one more conclusion from there. So here it is a, I think it is a, here sinusoidal is missing. Here, what I have got is a sine function here. Yeah, just a minute. Here it is a sine function. Here it is a sine function. If it is a sine function, or it can be a cos function also. Okay. So what I have got information regarding is a sine function. So here the magnitudes are 2, 1, and the angle is this one. Here it is 2, 1, angle is this much. It is magnitudes are 1, 2. Okay. What is the condition? And it is asking for which of the following will gives rise to left-handed elliptical polarization. So angle should not be equal to 0. In all these cases, angle is not equal to 0. Okay. So it's asking for left elliptical. Okay. Let us see. So the wave is traveling in the positive z direction. So the y component should lead. Okay. So then only you will going to get the left elliptical polarization. Fine. So here it is leading, but this is lagging, isn't it? Why? Because it is 270. This can be written as minus 90. Fine. So here it is pi by 4. Again it is leading. So it is leading, lagging, leading. Fine. So you can cross check this one with one simple example. Okay. So E is equal to, here it is 2 into x cap sine omega t minus beta z. Okay. Plus y cap into sine omega t minus beta z. What is the magnitude? Here it is 1 plus theta. So how much is the theta? For this case it is 3 pi by 4. This can be written as pi by 2. This can be written as E into 2 x cap sine omega t minus beta z plus here it is cos sine 90 plus theta. Okay. Plus pi by 4. Okay. This can be written as y cap into cos omega t minus beta z plus pi by 4. Just I am cross checking. Okay. Let us make this space equal to 0. This part is equal to 0 because I am interested only in the time variation. At time t is equal to 0, the E is equal to, so it is 2x cap sine omega t plus y cap cos, here by making z is equal to 0. I have made z is equal to 0. So I am going to get here omega t plus pi by 4. Let us take at 2 time instants. Okay. Let me turn the page here. At time t is equal to 0, if I make time t is equal to 0, what happens? The resultant electric field will be equal to, it is 0 x cap plus, it is, if I make this one 0 cos pi by 2, it is 1 by root 2 y cap. Let us take at one more time instant. At time t is equal to pi by 8, sorry, t by 8. So the electric field E is equal to, it is 2 by root 2. It is 2 by root 2 x square. Just for cross-checking purpose, if I substitute here pi by 4, it is cos, it is 0. So it is 0 y cap. Fine. So this is x-axis, this is y-axis, wave is traveling in the, it is a z-axis. Okay. At time t is equal to 0, resultant is on the y-axis. That means the resultant is here. As the time progresses, resultant will be on the x-axis. So the sense of rotation is like this. Okay. So what is the meaning of that sense of rotation? This is favoring my left hand. So here it is magnitudes are unequal, left-handed elliptical polarization. That means the y component leading. Okay. You can go back and check out here. When the y component is leading, then when the y component is leading, that leads to what is called left-handed elliptical. Here it is leading, here it is minus 90, here it is leading. Okay. So all these are, which of the following will give rise to left-handed elliptical? So this is not a left-handed elliptical. Remaining all are left-handed elliptical. So this one, this one, this one is the answer. Clear? Okay. There is one more question here. I got information that there are questions even on the antennas, but proper statements and proper questions are not there with us. Okay. There is one more question. Let me read out this question. Recently I have got. So I'll just read out the question. It is regarding the thickness. I'll just read out the question. Observe here. A transparent dielectric coating is applied to a glass. There is a glass on which transparent coating is applied, and with the relative permittivity is 4 and relative permeability is equal to 1. To eliminate the reflection of the red light, okay, the red light wavelength is given. It is 0.75 micrometers. The minimum thickness of the dielectric coating in micrometers that can be used is, okay, so there is a dielectric slab, there is a glass, so on which you are introducing some thickness here. Okay, see here, let us say these are thickness. This is a thickness T. Okay, there is a glass on which you are coating this one with some thickness, and this is having the intrinsic impedance eta 1. So this is eta 2, this is eta 1, again same medium. Fine, he is asking what is the minimum thickness required so that there won't be any reflection. So the incident wave is having this wavelength. Fine, and what is the medium parameter for this one? Here epsilon r is equal to 4. Let us try to find out what is the wavelength here. Lambda naught is equal to 0.75 micrometers, or you can also call it is lambda 1. Then what is this lambda 2? Beta is equal to, we know that omega square root mu epsilon. So it is 2 pi by lambda is proportional to the square root of mu epsilon. That means 1 by lambda is proportional to the square root of epsilon. Okay. So what happens to the new wavelength in this medium? You can write this one as lambda 2 is equal to lambda 1 divided by square root of epsilon r, which is equal to how much? It is 0.75 micrometers by square root of 4. So lambda 2 is equal to 0.75, 375 micrometers, you can write by 2. But what is the question here? The question here is what is the minimum thickness required so that there won't be any reflection. Fine. So for the minimum, if you need to apply the transmission line analogy here. Fine. So what is the minimum distance over which characteristics will be same? For the minimum thickness, the characteristics and here must be same. Yes, okay, if you develop the transmission line analysis. So if the characteristics here and characteristics here are same, what happens? So they will be repeated here. So what is the minimum distance required so that there won't be any reflection? The minimum distance required, there won't be reflection, is the lambda by 2 length. That is the idea here. For the lambda by 2, from the transmission line terminology, we know that the lambda by 2 length will going to act like a mirror. In the transmission line terminology, lambda by 2 length is called mirror. So this length must be lambda by 2. So what is the wavelength here? It is lambda 2 by 2. So what is the answer? Here it is lambda 2 by 2. That is 0.75 micrometer by 4. Check out this value. It is lambda 2 by 2 and rounded out to 2 decimal point is 0.19 micrometers is the answer. Let me cross check myself. It is yes. It is 0.1 pi, 19 micrometers, 0.18 something. So if you round it up to 2 decimal points, it is 0.19 micrometers. So what is the idea here? The idea here is a image concept. Why? Because lambda by 2 length acts like a mirror concept. Lambda by 4 is an inverter. As you know all these things, okay? So the repetition of the characteristics happens. You have to apply the transmission line analogy. From here to here, you have got one transmission line. Here to here, one more transmission line. After translation, it will become eta 1. Clear? Okay, fine. So this length must be lambda by 2. So that there won't be any reflected wave. Fine. So these are the questions what we have so far. Okay. So I'll end up the session with these solutions. Okay. Hope you had a great time. We'll go into end session. I'll wish you very success and good luck. Thank you.